Hello again. In this lecture we want to learn how to use polynomial regression. In this lecture we want to learn first degree, second degree and third degree regression by using some NumPy library features. So to start our coding we need to import some library. So from NumPy import everything and save your file as a poly1.py. Then we must import NumPy as a MP. Then from scipy dot interpolate import everything. Then we need some scipy stat, so right from scipy dot stat import everything, and finally we must import pyplot. So right from matplotlib dot pyplot import everything and import matplotlib dot pyplot as a plt. So build it, and we have some error here. So we missed some s here, so build it again to see the output. Alright, we have no error now. So go to making our input data. So x equals to np.sort 5 multiplied by np.random rand 1 and 40 and x is equals to 1. These codes generate 40 random variable and multiply them by 5 and sort them. So we want to find sine of x, so write np dot sine of x, and to flatten this array to one-dimensional array we must use Ravel method. So build it again. Alright, we have no error. You can print x and y. So we have some ident problem here. Build it again to see the results. Alright, you can see the x and y. Okay, you can visualize them by using plot. So style.use ggplot and plt dot figure 1. We add a number to our figures, so finally write plt dot scatter x and y and some color for it. Add a blue color for this plot and block equals to false. This comment help us, and we don't need to close first plot to see the second plot. So we must delete it, and in the future we must put it here. So build it again. Alright, you can see the sine function here, and as you know, the sine function has an output range between 1 and -1. So we keep continuing to make our polynomial regression. I put it again here and continue to the next, and so let me delete it. And I will put it here at last of our coding. So write x equals to x 0 and colon. This command select make x to a one-dimensional array, and it helps us to make a polynomial regression. To make a first dimension or first order regression, you need to use polyfit command. So write p1 equals to polyfit x, y, and 1. This command make for us a multiplied by b multiplied by x plus b regressor line, and to see the a and b coefficient you must print p1 and build. Close this, and as you can see, a and b is here, and it is our coefficient. So we can calculate some measurement for this type of regression. So I want to calculate r squared for this type of regression. So I define y fit equals to p1 0 multiplied by x to make the output of this polynomial regressor, and plus it with p1 1. Then I define y residual equals to y minus y fit. According to r squared definition, you must define it as follows: ss resid equals to sum power of y resid and 2. We must we must multiply y residual in it, and finally SS total equals to 1 minus SS residue divided by SS total. And we must define SS total as follow. So use this function to find the length of y and multiply it by y. Alright, and finally find r square by using this command 1 minus SS residue by SS total, and finally print r square. These lines of codes find for us r squared error. I must close it to see the r square. As you can see, we have a 64% accuracy, and